So this is test 3 on physics, and number 1. A spring with stiffness Ks and relaxed length L stands vertically on the table. You release the mass M from rest, just barely touching the top of the spring. The mass oscillates up and down. Determine the maximum compression of the spring. Use the energy principle. So here we are given with first, since it is a at rest, initial condition K equals 0, and the potential, gravitational potential equals mgl. Because the diagram is given like that, and of course spring potential is 0 because it's not moving. And then final condition, kf is also 0 because it's at rest, but the gravitational potential equals to mg times L minus S max. X max is which is the maximum strength, maximum stretch of the spring, and then stiffness of potential energy is 1/2 Ks max square. So with the energy principle, which is delta E equals delta K plus delta potential energy plus delta spring potential energy, and we set this equal to 0, and we know that from kinetic energy initial and final is 0, so there's no change. So we know that delta E equals UGF minus UGI plus USF minus USI equals 0. But we know that USI is 0 because we set it right here. And we can say that MGL minus S max minus MGL plus 1/2 K S max square also equals to 0. And as you know that if you simplify this, you can cancel L from both sides. So you will automatically have MGS max plus 1/2 KS max square equals to 0. So then we have 1/2 KS max square equals MGS max. So we have S max equals 2mg over k. So this was number A. Then let's look at number B. A spring with stiffness Ks and relaxed length L stand vertically on the table. You hold the mass just barely touching the top of the spring and very slowly let the mass down onto the spring until the spring has a length L over 4. You hold the mass motionless at this location. Calculate how much work your hand performed. So now you have initial condition has hold a spring, which is Ki equals 0, and then U, gravitational potential equals to mgl, and spring potential as 0. And then you have final position as Kf equals 0 because it's not moving anyway, and gravitational potential as mgl over 4. And then spring potential as 1/2 Ks square, right? Okay, so when you think of the spring right here, which is this is the ground, and this is the mass, and then if this is whole L, and this is the maximum strength of stretch, then you have S equals L minus L over 4, which is 3L over 4, when the spring compressed is like that. So this is L over 4, right? So S becomes 3L over 4 here. So we start from the energy principle again. Delta K plus delta U G plus delta U S is work by hand, right? So you have UGF minus UGI plus USF minus USI equals work. And we know from here K is 0 and USI also 0, like the previous problem. But we have LG 1 over 4L minus MGL plus 1 half KS squared equals work done by hand. So mg L over 4 minus L, we simplify it, and 1 half K 3L over 4 squared, which is, we got it from here, equals to work. And then negative mg 3L over 4 plus 1 half K 3L over 4 squared equals to work done by hand. Work done by hand is 3L over 4 bracket 3KL over 8 minus mg, right? Okay, C. After compressing the spring so that the length is L over 4, you release the mass from the rest. The mass starts moving upward, losing contact with the spring, and continues upward before turning around and falling back towards the table. Determine the maximum height reached by the block as measured from the table. When the block is not in contact with the spring has the length of L. So you have, it is compressed. This is L over 4. And you have this much as S, and when it is detached from the spring, let's call this much as height, and this is L. Then this is H max, right? So H max is L plus H. So here S equals what? 3L over 4, right? So as we see, K initial is again 0, and UGI, which is gravitational potential, is mg L over 4, and spring potential energy 1 half KS squared. Final KF is 0, gravitational potential energy for final spring height is mg H max, and then USF is also equals to 0. So we start from energy principle, which is changing energy equals changing kinetic energy, and then UG plus US equals to 0. Kinetic energy, there is no change. So UGF minus UGI plus USF minus USI equals to 0. And USF is 0, as we said it right here. And MGH max minus mg, so we plug in given ks squared equals to 0, mgh max minus L over 4 minus 1 half k 3L over 4 squared equals to 0, mgh max minus L over 4 equals to 1 half k 3L over 4 squared, h max minus L over 4 equals 3L over 4 squared K over 2mg. So we try to isolate the h, which is h max equals to L over 4 plus 3L over 4 squared K 2mg, which is L over 4 1 plus 9k L over 8mg. This was C. So this is the last problem of problem 3.